Up to this point, all of our angles have been measured in degrees, but there is a radian measure out there that we're going to use quite a bit in this class, and we'll talk about the advantages of that later. If I have an angle on a circle where the length of the arc right here that's intercepted by this central angle is the same as the measure of this radius right here. In other words, I could take this length of the radius and bend it and lay it right along the curve of the circle there. If these lengths are the same, then the angle that's intercepted right here is 1 radian. So that by definition is a radian. Now, if you go all the way around the circle, then we know that that circumference is 2 pi r by formula. If I talk about a circle with a radius of 1, then my r becomes just 1. And 2 pi is the radian measure of the circumference of the unit circle. If I measure that same curving, that same turning of the angle in degrees is 360 degrees. So all the way around the circle in radians is 2 pi. All the way around the circle in degrees is 360. If you reduce that, then it gives you a conversion factor pi over 180. I've just divided the 2 into the 360 and reduced that fraction. So this is a conversion factor because pi and 180 degrees represent exactly the same angle from starting point here to terminal ray right there. Now, depending on whether we're going to convert from degrees to radians or radians to degrees, we might flip this conversion factor. So we might use 180 degrees over pi. But again, since those represent the same thing, that's a conversion factor of 1. Let's use those to convert some angle measures. Here we're given degree measure and we want to convert to radians. Whatever you're converting to, you want to put on top. So I'm going to multiply by pi, because that's radians, over 180. The degrees are going to cancel on the top and the bottom diagonally. And then the 45 over 180 you want to simplify in your calculator, and you get 1/4, and you want to multiply that by pi. So I end up with 1/4 pi, which is just pi over 4. This is an exact answer, not a decimal answer, and most of the time that's what you're going to want. However, if you're given the angle in decimals, then it's okay to give your answer in decimals unless it specifies otherwise. Again, I'm multiplying by pi over 180 degrees. The degrees are going to cancel, and this time I just want to enter that decimal there. So using the pi button in my calculator, I get a decimal answer of 4.3598 rounded to 4 decimal places, and they will tell you how to round. Now we could convert the other way. We could be given an angle in radian measure, and you can tell that it is because there's not a degree symbol. Anytime you see an angle measure without units, it's assumed to be radian measure. We want to convert that to degrees. So we're going to put the 180 on top, just flipping our conversion factor, divided by pi. Notice that if I have pi in my original radian measure, then the pi's are going to reduce, and then it's just a matter of multiplying 9 times 180 divided by 4. Or you could reduce diagonally first. So that's equal to 405 degrees. Notice that this radian measure does not have pi in it, and that's okay. You still are going to multiply by 180 degrees because that's what you're converting to, divided by pi. And this time you'll use the pi button that's on your calculator. Decimal answer. Notice that I need to make sure that I include the degree symbol in your answer.